Okay. Before we start, let me show you where this comes from. Every Maths Methods exam the VCAA has set from 2018 to 2025. That's 16 papers. Exam 1 and Exam 2. 268 questions, sorted one by one into topics. And this is how the marks actually split up. Here's the last two papers, counted mark by mark. Probability and statistics is now the single biggest topic, 24%. Calculus is right on its heels at 23%. It's basically a coin flip for first place. And it turned up in all 16 papers. Not most of them. All 16. Every year, both exams, without fail. Now here's the bit that should make you sit up. Those probability marks aren't random. It's the same 5 ideas, over and over. Conditional probability, 20 times. The normal distribution, 14. Sample proportions, 13. Random variables, 10. The binomial, 6. So that's what we are doing today. 5 ideas. And your brain gets every single one of them wrong. So let's watch that happen, with lollies. Here are 1,000 jelly beans. Almost all of them are sweet. But 10 of them, the red ones, are super sour. Now, we've got a sour bean scanner. It's pretty good. Out of every 10 beans it checks, it gets 9 right. And it just beeped at your bean. Beep. So, is your bean actually sour? Lock in your guess. 3, 2, 1. Let's watch it work. It checks the 10 sour beans, and it catches 9 of them. Nice. But here's the sneaky bit. It also checks 990 sweet beans. And it's wrong about 1 in 10 of those. That's 99 mistakes. 99 sweet beans, beeping for no reason at all. So let's put every bean that beeped into one pile. 9 of them really are sour. 99 of them are sweet. That's 11 false alarms for every real one. Your beep is probably a false alarm. A beep only means sour about 8% of the time. And here's why. Sour beans are rare. There are so many sweet beans that even a tiny mistake rate piles up into a mountain of mistakes. So when your exam says, given that the test is positive, it just means this. Only look at the beans that beeped. Then count them. That's the whole trick. So now let's gather up every bean that beeped, and only those. Here they are. 9 of them really are sour. 99 of them are sweet. Just look at the size of those two piles. And that's your answer. Your bean is somewhere in this line of 108. Only 9 of them are actually sour. 9 out of 108. About 8%. Let's put the whole thing on one tree, because this is exactly what you draw on your exam. 1,000 bean splits into 10 sour and 990 sweet. Each side splits again, into beeped or didn't. 9 of the sour beans beeped. 99 of the sweet ones beeped too. Circle just the beeped branches and add them up. 108 beeped, and only 9 of those are actually sour. That's the whole calculation, sitting right there on one diagram. And the reason is the thing I asked you to hold on to. Sour beans are rare. There are so many more sweet beans that even a tiny mistake rate on the big pile completely buries the real ones. So when your exam says, given that the test is positive, all it means is this. Throw away every bean that didn't beep. Then count what's left. Right. New one. I flip a coin. Heads. Heads again. Heads. 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 5 in a row. So, next flip. Surely it has to be tails now, right? It's tails' turn. Lock in your guess. 3, 2, 1. Nope. Still 50-50. Have a look at 2,000 real coin flips. See all those streaks? Real randomness is clumpy. Streaks are completely normal. And after every 5 head streak, the next flip came up heads about half the time anyway. The streak changed nothing. Think about it for a second. A coin is a little piece of metal. It hasn't got eyes. It hasn't got a brain. It cannot remember what it did last time. Every flip starts completely fresh. And that's all the word independent means on your exam. No memory. Okay, let's play a game. You roll this die, and I'll pay you whatever number comes up, in dollars. Roll a 6, win $6. So how much is one roll actually worth? Lock in your guess. 3, 2, 1. Here's the easy way to see it. Imagine 6 perfectly fair rolls. One of each number. You'd win 1, plus 2, plus 3, plus 4, plus 5, plus 6. That's $21 from 6 rolls. Now share that $21 out between the 6 rolls. $3.50 each. But hang on. There's no 3.5 on a die. Doesn't matter. Watch the average of hundreds of real rolls. It settles right onto $3.50 and stays there. Expected value is just the long-run average. It never has to be a number you can actually roll. Last one. Take everyone in Australia and line them up by height. Shortest on the left, tallest on the right. Then stack up everyone who's the same height. You get a hill. Most people are somewhere in the middle, and that's the fat part. Really short and really tall people are rare, and that's the skinny ends. This hill is so common it's got a name. The normal distribution. And it comes with a magic trick. Take one step either side of the middle, and you've just scooped up 68% of everyone. Take 2 steps, and it's 95. 68 and 95. Learn those 2 numbers, and the hill questions are free marks. So, when the exam says given that, count the beans. The coin has no memory. The average never has to be a number you can roll. And the hill is 68, then 95. That's roughly a quarter of your exam, right there. Now go and show it who's boss. You've got this. Want to practice more like this? Come find us at examprep.com.au. Real past exam questions, and an AI tutor that walks through it with you, one step at a time. See you there.